We will discuss about the continuity. Yesterday we have discussed about limits. We have discussed about standard limits. Okay. But let us recall limit x tends to 0 sin x by x equal to 1. Limit x tends to 0 sin ax by x equal to a. Okay. Limit x tends to 0 tan ax by x equal to e. Limit x tends to 0 tan x by x equal to 1. Limit x tends to a x raised to n minus a raised to n by x minus a equal n into a power n minus 1. Okay, today we will discuss about the continuity. See, let the function f of x equal 1 if x not equal to 0. If x equal to 0, the function value is 2. F of x is defined by if x not equal to 0, f of x equal to 1. If x equal to 0, f of x equal to 2. Okay, let's draw this graph. 0, 1, 2, 3, 1, 2, minus 1, minus 2, minus 1, minus 2. X not equal to 0 means not 0. At 0, function value 2. At 0, the function value 2. Plot this point. Next, this point is not 0. Point 1, point 2, point 3, not 0. If not 0, then the function value 1 here. At 0, no, this is not 0. At point 1, point 2 is 1. Up to this. Next, minus point 1, minus point 2, minus point 3, these all are not equal to 0. Then this minus 1 also 1, minus 2 comes under this, minus 3 comes under this, f of x equal to 1. Right? See, this graph, this is called left limit. What is the left limit is? 1 at 0. This is right limit at 0. So right limit, left limit is 1, right limit also 1. So limit exists. So what is the limit? The limit x tends to 0, f of x equal to 1. F of x equal to 1. But at 0, function value at 0, substitute here, x replaced by 0, f of 0 equal to 2. F of 0 equal to 2. So this is 2, here gap is there. But this graph, there is a break here. There is a break. If f of x equal to, this is equal to 1, then this point will be there here. Then the graph is like this. 0, 1, 2, minus 1, minus 2, 1, 2. This is f of 0. If f of 0 equal to 1, 0 equal to 1. F of point 1 also 1, 1. So there is no break in the graph. Here break is there. Here break is there. Here there is no break. Okay? If there is no break, means it is a continuous. It is a continuous at 0 and everywhere. If there is a break, means it is not continuous at that point. At what point break is there? At what point break is there? 0. Here, graph, there is a break here. Okay, this 0 value is 2. So here break is there. So break means the graph has a break means at that point not continuous. So this graph as graph method. So what is the definition of continuity? If there is a break, then it is not continuous. If there is no break, it is a continuous everywhere. So here break at what point? 0. Therefore f is not continuous at what point? 0. This is break. At 1 break is there? Break is there? No. At 2 is there break? No. At 3 break is there? No. At 0.1 break is there? No. No break. No break. So this is continuous every way but not 0. See the graph please. Is there any break in this? No. Therefore it is continuous every way. Every way means each and every real number. Each and every real number. So no break. So when the no break means the left limit and right limit and equal to function value. Here left limit 1, right limit 1, limit exists, but function value at point 0, f of 0 is 2. Here function value f of 0 is 2. Both are not equal. So limit x tends to 0, f of x not equal to f of 0. So this is called limit value and this is called function value. So limit value not equal to function value, then the function is not continuous at what point? 0. At what point? 0. Not continuous, the meaning is, we see another word is discontinuous. So it is discontinuous at what point? 0. Here, if it is equal, here what is f of 0? 1. So f of 0 is 1. Then both are equal. So limit value equal to function value. Then there is no break. Then f is continuous at that point. Understood? Continuous means limit value equal to function value. Limit value equal to function value. Are you following? So left limit equal to right limit. See. Let f is a real valued function. Let a is a point which is belongs to the domain of f. F is said to be continuous. F is said to be continuous if limit x tends to a, f of x equal to f of a. What is this? Limit value. How to find limit value? Yesterday we have discussed. Okay? Limit value means left limit equal to right limit. Then limit exists. Otherwise limit does not exist. F of a, this is called function value at a. This is limit value equal to function value. Then f is said to be continuous at what point? At x is equal to e. Okay? F is function that a belongs to the domain of f. F is said to be continuous at x equal to a if limit x tends to a, f of x equal to f of a. So limit value equal to function value. Now limit value means left limit equal to right limit. LHL equal to RHL equal to function value f of a. Tell me LHL, limit x tends to a at this point, a minus. Limit x tends to a plus f of x equal to f of a. This is left limit equal to right limit equal to function value. Then f is continuous at that point a. Are you following? Yes. Limit means this much one. This is external number. What is this? Function value. Are you following? Function value equal to limit value. Then f is continuous at that point. This is by mathematics, by mathematical symbols. Okay. By graph method also we can define the continuity. So what is the by graph method continuity means? If there is no break in the graph, then f is continuous every way. If there is a break at the point A, then the f is not continuous. The not continuous means discontinuous. Not continuous means discontinuous. Understood? Okay. What is the continuity definition? Limit value equal to function value. Limit value how to find? By using left limit and right limit. If it is changing function. If it is not changing function, no need to find left limit and right limit. And which is equal to function value. Then f is continuous. Okay? And by graph method also we can find. By graph method, how to find? Draw the graph of function. Okay? At what point the graph has a break? At that point, the function is not continuous. If there is no break in the graph, then the function is continuous. Okay? Let's discuss about the continuity of mod x. Discuss about the modulus function. Discuss the continuity of modulus function. Tell me modulus function. Mod x equal to x when x is greater than or equal to 0. Minus x when x is less than 0. Okay? Tell me, to discuss this continuity, we can prove two ways. By using graph method, by using limit concept. Okay? First, let's discuss about the graph method. Graph method. Draw the graph of modulus function. Let this point, plot this point 0, 1, 2, 3, minus 1, minus 2, 1, 2, so on, minus 1, minus 2. Okay? Mod. If you take x is equal to 0, 0 comes here. The mod 0 is 0. Mod 1 is 1. Mod 2 is 2. Like this. Mod minus 1. Mod minus 1 comes under this. Put x is equal to minus 1. Minus of minus 1, 1. Mod minus 2 also 2. So this is V shape. Okay? Tell me, by seeing this graph, is there any break? No. No break. It's by taking 4, 5, it goes to up to infinite. No break in the graph. So there is no break in the graph. There is no break. There is no break in the graph of mod x. The graph of mod x. Therefore, mod x is continuous. Mod x is continuous every point. Means every way. Every way means each and every real number. Real number means all counts. That we say every way. If it is continuous every point, that we say every way. Okay, so mod x is continuous every way because by the graph, okay, there is no break at any point. Okay, therefore it is continuous every way. Okay, this is by graph method. Now without graph method. Without graph method, how we can find? By using limit concept. Limit concept. Now alternative second method. Limit concept the same. The mod x equal to x when x is greater than or equal to minus x when x is less than 0. See, at what point it is changing? 0. 0. So if it is changing at 0 means we should find first limit at 0. Okay? First let's find the limit at x equal to 0. Tell me left limit LHL limit of x tends to below 0 mod x. Limit of x tends to below 0 mod x is minus x. Put x equal to 0, minus 0 is 0. Next, RHL limit of x tends to 0 plus mod x. Limit of x tends to above 0 mod 0 equal to 0. Tell me left limit equal to right limit. Then limit exists. Then we should find function value f of 0. Tell me f of 0. It is equal to 0. This is equal to 0. Comes under 0. F of x is equal to mod x. So put x is equal to 0 here. Mod 0 is 0. Are you following? Then f of x equal to mod x. Put x is equal to 0, f of 0 is mod 0 is 0. Okay? The function value, limit value, left limit, right limit all are equal. LHL equal to RHL equal to function value. All are CD. So left limit equal, right limit means limit exists at that point 0 and function value also equal. Therefore f is continuous. F is continuous at x equal to 0. Okay? At x equal to 0, f is continuous. Now what about above 0 and below 0? For if you take above 0, this is x. It's not changing. This function is changing at what point only? 0. If it is not changing, no need to find left limit and right limit. Okay? If you take above 0, for all x greater than 0, f of x equal to mod x equal to x. This is continuous. Why? Because if you take above 0, any number you can take 1. 1, mod 1 is 1. Function value also 1. So function value and limit value both are same. So limit x tends to c, where c is greater than 0. Mod x equal to mod c. Then function value f of c equal to mod c. Both are same. Therefore it is continuous at what point? C. C means above 0. Next, similarly, let another point A which is less than 0. A belongs to R. Then same, limit of x tends to A mod x equal to less than 0 is minus x. So limit of x tends to A minus x which is equal to minus A. Okay? And if you take function value f of A equal to minus A. So both are same. So left limit equal to function value. Therefore it is continuous. Here one thing is, only if you given this function, first you can find the continuity, you can check the continuity at changing point. Okay, if it is not changing, no need to check. Because if it is not changing means left limit equal to right limit and which is equal to function value. See, if you take here 2 comes under above 0. Above 0, here if you take left limit, right limit of 2 and function value, all are same. All are very close to that, there is no break here. So 3 if you take, no. 1 if you take, continuous. 1.5 if you take, continuous, no break, no break. Okay, at what point turning here? 0. There is the main important, there we should find. If it is, if you find here left limit not equal right limit, then it is not continuous at 0. Are you following? So, modulus function is continuous everywhere. This is two methods. I have discussed two methods. One is graph method, another without graph method. By graph method, there is no break. And this is by limit concept, left limit equal to right limit equal to function value. So first, why should check the limit at what point? 0. Because the function is changing at what point? 0. If it is not changing, no need to find left limit and right limit. It's a continuous. Understood? Discuss, find all the points of discontinuity of the function f defined by f of x equal to x plus 2 if x less than 1, 0 if x is equal to 1, x minus 2 if x is greater than 1. So, listen, this is to discuss the other points. We can explain two ways. One is by graph method, another one without graph. So, first let us discuss about the graph. Graph method, how to identify whether it is continuous or not. At what point it has a break, there it is discontinuous. Okay, see, let's draw the graph of this 0, 1, 2, 3, minus 1, minus 2, 1, 2, 3, minus 1, minus 2. Right. See, x equal 1. What is the function? F of 1 is 0. F of 1 is 0. This is the point. Plot this point. Next, above 1 comes under this. If you take 2, put x equal 2 here, 2 minus 2, 0. Right? If you take 1.1, 1.1 is 1.1 minus 2. 1.1 minus 2. 1.1 minus 2 minus 0.8 minus 0.8 means comes down like this. Minus 0.8. Okay, 1 if you take 0 like this. If you take 2 here, 2 minus 2, 0. So the graph you see here is a continuous. 1.9 if you take 1.9 if you take 2 if you here 1. Then next you can take here above 1 is 2. Okay, above 1. If you take 1 here, 1 comes here, value is 0. So leave it here. Come to this above 1, 1.1. 1.1 means 1.1 minus 2 minus 0.9 here. Okay, next 2 if you take 0 here. Okay, 3 if you take 1, 4 if you take 4 minus 2, 2. So the graph is like this. Join all these points. Okay, but at 1 not this, at 1 0. Next, below 1 is this. Below 1. This is the one. Below 1, 0.9 if you take 0.9 plus 2, 2.9. Okay, 2.9 here. Not 3, 2.9. Okay, if you take 2 below 1, 0 if you take 0 plus 2, 2. If you take minus 1, minus 1 plus 2, 1. Minus 2 plus 2, 0. Join all these points. So you see the graph. At what point has a break? At what point has a break? 1. For above 1, no break. For below 1, no break. But at what point has a break? 1. Therefore, f is not continuous. F is not continuous at x equal to 1. Understood? Why? The graph has a break at what point? 1. For above 1, no break. For below 1, no break. Therefore, f is continuous. F is continuous at what point? Tell me. F is continuous at all real numbers. This and this, all real numbers except 1. Except 1. So this is we can do by another method, by using limit concept. See, this is this function, by seeing this function, it's changing at what point? 1. It's changing at what point? 1. So we should find limit at 1. Okay. So it's a changing function. So we should find left limit and right limit. So first, let's discuss about the continuity at x is equal to 1. Left limit LHL. Limit x tends to 1 minus f of x. 1 minus means below 1. Below 1, x plus 2. Put x is equal to 1 here. 1 plus 2, 3. Right? Next, right limit RHL. Limit of x tends to 1 plus f of x. Limit of x tends to above 1. Above 1 is x minus 2. Put x equal to 1 here. 1 minus 2 equal to minus 1. Tell me left limit is 3. Right limit is minus 1. So left limit not equal to right limit. Therefore, limit x tends to 1, f of x does not exist. If limit does not exist means it is not a continuous, means there is a break. So no need to verify the function value. Therefore, f is not continuous. F is not continuous at x is equal to 1. Okay? What about below 1? What about below 1? Below 1, less than 1. If x less than 1, what is the function value f of x equal to? X plus 2. What is the function value? X plus 2. Below 1, take any one number. Is it changing here? Below 1? Below 1, at any point is changing? No. So below 1 not changing. So you can take below 1 any point. 0, minus 1, minus 2, minus 1.1, minus 1.2. Any number you can take it. But this is not changing. So no need to find left limit and right limit. Just you find the limit direct. Take one point here. Let C belongs to R which is less than 1. C is an real number which is less than 1. Okay? Such number at this point we are going to find limit. Limit x tends to C f of x. Limit x tends to C f of x is equal to x plus 2. Put x is equal to C here, C plus 2. This is the limit value for all less than 1. For example, if you take 0, minus 1, below 1, how many are there points? Many are there. So below 0, below 1, 0 if you take, minus 1 may be filled. Minus 1 if you take, minus 2 may be filled. Then what to do? Take C. Then every number fill up here. Okay.